My name is Jeffrey Frankel, and I have shown students techniques to reduce the time answer questions in paper 1 of the IB chemistry exam at both levels, standard level and higher level. These questions are multiple choice. You have 90 seconds available for each question, and you have no calculator. These techniques that I am about to show you will help you dramatically reduce the time needed to answer those questions correctly in maybe 30 or 40 seconds, and in some cases even less, thus giving you extra time to do other questions within the paper.
When students first see this equation and this question, they immediately think, I've got to balance the whole equation. But really, that is not necessary. All you're asked is, what is the coefficient for oxygen? That is the only thing you need to think about. What is the coefficient for oxygen? And that is determined solely by the number of carbon atoms there and the number of hydrogen atoms. Now, I would suggest that you make a simple assumption initially, and that is that this is 1. That simplifies it. Then from 2 carbon atoms, you know there must be 2 CO2. Okay, and from H2 there must be 1 there. So you now have 2 times 2, which is 4 oxygen atoms, plus 1, which is 5 oxygen atoms. So this would be 5 over 2. So in order to get the coefficient for oxygen in the balanced equation where everything is a whole number, it's clearly 5. There is the answer. This is another one where students think, have to balance the whole equation. But you don't have to balance the equation. You don't have to find all the coefficients. As in the previous example, we're simply going to look at the carbon atoms and the hydrogen atoms, and then after that take into account this oxygen atom that's there. So let's assume initially that is 1. We have 2 carbon atoms, so that must be 2. We have 4 hydrogen atoms, that must be 2. So what we do is we add up the oxygen atoms on the right. There's 4, 6. We subtract this one, because this one's important, and that gives us 5 over 2. So what is the coefficient for oxygen? We double everything, and it gets 5. The examiners clearly like these kind of questions. Okay, so what is the coefficient for oxygen when this equation is balanced using the lowest whole numbers? Again, we will assume that there's 1 of those, and immediately we see there's 4 of those, therefore there must be 4 there. And there's 10 of those, so there must be 5 over here. Okay, now we add up all the oxygens. We've got 4 there, 5 there, so that's 9. 9 over 2. And therefore, when you double it in order to eliminate the half, the coefficient for oxygen is 9 there. Okay. This is another one that if you've done 2 or 3 of these, this should become easy. You do it in 10, 15 seconds because you can do it in your head. You don't have to write the numbers down. You can do it in your head. This is different from the others in the sense that you do have to determine all the coefficients. And the best way of doing it is the assumption I made in other examples. Put a 1 there, and then immediately go to the carbon. Always do the carbons first. There's 2 carbon atoms there, so therefore there's 2 CO2s. There's 2 hydrogen atoms there, therefore there's only 1 of those. And then you go to 2 times 2 is 4, plus 1 is 5. They like these odd numbers, don't they, the examiners? 5 over 2. So you add the numbers up. 1 plus 2.5 is 3.5, plus 2 is 5.5, plus is 6.5. Clearly you can't have half numbers, so you double the 6.5 and you get 13. This one clearly has a lot of words in it and will take you maybe 20 or 30 seconds to read through it. But the principles are very simple. And especially when you see things like the temperature is 20 degrees centigrade and 1 atmosphere pressure. Obviously, you're not going to have water vapor. No way can you have water vapor, so that it cannot possibly be a product. Then when you look at 18 moles of water and you think about it, you realize you can't get 18 moles of water even from 1 mole of octane. You would only get 9 moles of water from 1 mole of octane, and you're using less than a mole of octane, you're using half a mole. So you can even forget about that one and that one. So really all you need to look at is the carbon dioxide. So let's look at carbon dioxide. We've got 8 carbon atoms. They will produce 8 moles of carbon dioxide. So 8C, you don't have to write any of this down, you just do it in your head. 8CO2. So 1 whole mole of octane will produce 8 moles of carbon dioxide. We have half a mole of octane, so that's only going to produce 4 moles of carbon dioxide. And you need to know that each mole of carbon dioxide has a volume of 22.4 decimeters cubed. And that equals 4 times 22.4 is approximately 90. And they say close to 100 decimeters cubed of carbon dioxide or close to 180. I'll take B, close to 100 decimeters cubed of carbon dioxide. Okay, we've done a number of these. So the simple way is to assume that's 1 and then immediately look at the carbon. There's 3 carbon atoms, therefore there's going to be 3 CO2s. There's 8 hydrogen atoms, therefore there's going to be 4 H2Os. Okay, and therefore we look at 3 times 2 is 6, plus 4 is 10. 10, that's 5 moles of oxygen, and there you have it. Coefficient is 5. That one's easy. That one you should do in 10-15 seconds. If you're having problems with it taking longer than 15 seconds, then you need to do a lot more practice on some of these. Okay, we've done the forward version of this, where you know what the hydrocarbon is, you know the formula of the hydrocarbon, and you have to determine something else in it, the amount of carbon dioxide or water, or the amount of oxygen needed. In this case, you're working backwards from those things in order to determine which of these hydrocarbons it is. So what we're going to do is we're going to look at the carbon dioxide and the steam, equal volumes of carbon dioxide and steam. Let's assume that there's CO2 and H2O. Those are equal volumes. Therefore, to create those, you must have started with a molecule which is C1H2 as the empirical formula. Empirical formula. That's all you can find from this is the empirical formula. And therefore, to get the molecular formula, you either double it or treble it or whatever. And the only one that fits is when you double it. It's the C2H4, because if you double this, you get C2H4. If you treble it, you get C3H6, and that doesn't fit with any of them. So the answer is C2H4. This one is similar to the others, except that it's not an organic chemistry problem. It's an inorganic chemistry problem, but the principles are the same. We're going to determine the coefficient of oxygen, that's this number there, and we're going to look at the fact that Pb goes to PbO, and we're going to assume, first of all, there's only 1 there, and that requires half a mole of oxygen, and sulfur goes to SO2, and that requires a whole mole of oxygen. So half a mole plus a mole is 3/2. And therefore, when the equation is balanced using the smallest possible whole numbers, what is the coefficient of O2? Then the coefficient is clearly the 3, because you would double everything in order to balance it. That's 1 there and that's 1 there. So the answer is there, 3. When some students look at this one, they really get confused by the letters in the equation, V, W, X, Y, Z. But it's much simpler than it looks. All you're looking for is the value of W, the coefficient of oxygen, when V equals 2. So let's put 2 there, make it easier. And what we're going to first do is look at the carbon atoms. There are 4 carbon atoms, so that is 4. And then when you see that, that is this one. And then you think about it and you say, hey, the hydrogen is going to need oxygen as well in order to form water. And the only possibility they give you of a number greater than 4 is 5. So that's the answer. It's as simple as that. And this one shouldn't take you more than maybe 20, 30 seconds to see that. But you only need to deal with the carbon dioxide from the carbon. So my simple rule when you're dealing with organic chemicals and oxidation of organic chemicals, start with the carbon, then if necessary move to the hydrogen. And that would give you, in this case, 4 CO2. Therefore the answer must be 5D. Thank you for watching. If you found this YouTube video helpful, please see my other YouTube videos. Thank you.